Hello, welcome. Today is the Stoichiometry Quiz. So before the quiz, I thought you might like a little bit of review. So the first question is, what is the law of conservation of mass? What does it mean? I'm trying to move it on the thing. Actually, that should work. Anyway. Okay, so we've got our formula here, and we can see that we have one carbon, four hydrogen, four oxygen on each side. And that's supposed to give you a hint. What is the law of conservation of mass? That matter can be neither created nor destroyed, only changed in form. So if we have carbon on the reactant side, we have to have carbon on the product side. We're not going to suddenly have a new element that isn't there. Matter can be neither created nor destroyed, only changed in form. All right, so the next question is, what's on the left side of the equation? So this part that I've boxed in over here, what is that called? That's right, reactants. Those are the reactants. All right, what about the right side of the equation with the boxes around this time? What's that supposed to be? That's right, it's the products. So the reactants react to produce the products, and thus the arrow points toward the products. So it shows how the reactants turn into the products. All right, what goes in the blank space? So all we have to do is pick one of the elements from that formula. You don't have to use all of them. You can pick just one of them. So let's pick K, potassium. All right, so we're going to go over here. Do we have potassium there? Nope, so we're not going to look at that one. We do have potassium there, so we need to look at that. And that's on the other side. So this is the only one that matters. Well, how many potassiums are there? Well, there's no coefficient, so we only have to look at the subscript. So we need 3 potassiums. Well, there's no subscript here, so this would need to be 3. How many manganese atoms are found in the compound? So first you've got to know which one's manganese. Well, Cr is chromium, O is oxygen, so we've got manganese right there. So we know it's that. Now there is no subscript on manganese, so we don't have to worry about something times 6. But we do need to worry about the 6 because it applies to everything inside the parentheses. Now, if we were trying to figure out oxygen, we would have to multiply 4 times 6 to figure out the total that are within the parentheses. But for manganese, there's no subscript. So that means 1, 6 times 1. So we know we've got 6 manganese right here in the parentheses. But look, we've got a coefficient of 3. And that coefficient of 3 applies to the whole thing. So it's going to be 3 times 6. So 18. There's 18 atoms of manganese in that chemical formula. Sorry, it's so slow between slides. What is the little number after an element in a chemical equation called? So what's that thing right there? That is called a subscript. I know you got that right. Is this equation balanced? So pick an element, see how many there are on the one side, look at the other side, see if there's that many. Okay, so we've got 2 times 2 is 4 aluminums on the product side. So if we come over here, we only have 1 aluminum. So that's a big fat no. That is not a balanced equation. How many elements are in the formula? So you just want to look at how many individual letters do we have. Now, if there was another H and another O added on separately because of the chemical structure, there still would be the same answer because H and O are already represented. So don't think that, yeah. Okay, so we've got 1, 2, 3. There are 3 elements in this formula. It's taking forever. All right, is this an element or a compound? I'm worried that, okay, no, we got it. All right, so is this an element or a compound? H2O. Well, we've got more than one capital letter. So that means it is a compound. All right, element or compound, O2. Well, it's one capital letter by itself, so that means it's an element. All right, what's the number before a chemical formula called? So the two that are red here, the big number that's before the chemical formula. Same thing as when you have a 2 in front of like two variables in math. It's called the, good job, coefficient. It's the coefficient. How many aluminum atoms are in the formula? Okay, so aluminum isn't in the parentheses this time. So we don't even have to worry about this. We can just look right here. There's no coefficient, so that's the only thing that matters. There are 2 aluminum atoms in that formula. In which compound are there twice as many hydrogen atoms as oxygen? So looking at the first one, there's 3 hydrogen and 4 oxygen. So that's not twice as many. Here, there's twice as many oxygens as hydrogens. So that's not it. Here, we've got 3 oxygen and 1. That's not twice as many. We have 1 oxygen and 2 hydrogen. That would be it. We have twice as many hydrogens as we do oxygens in that formula. Oh, and there's the answer, H2O, pointing at it. What goes in the empty space? So we've got to figure out how many oxygens do we need to balance out this equation. So we've got to look on the product side, and we have 3 times 2 is 6 oxygens here, and 4 times 1 is 4 oxygens here. So we have 10. So we've got to figure out a way to get 10 oxygens. So you've got to look at this subscript. What coefficient would give us 10? So 10 divided by 2 equals what? That's the coefficient we need. And 10 divided by 2 is 5. So that coefficient would need to be 5. I don't think it erased everything from the previous slide. I did. Okay. What information could a student determine from only the chemical formula for a protein? So if you have the chemical formula for a protein, what do you know? Well, if you know the chemical formula, you know the elements that are in it, and you know the number of atoms of each element. No matter whether you can read it or not, you can identify what elements are there and how many atoms of each element there are. All right, the question is this equation balanced? So we're going to act like we're balancing the equation because we want to see how many atoms of each element are on each side. And if it equals, then we know it's balanced. So we've got 4 carbon, 4 hydrogen, and 10 oxygen. 2 times 2 is 4, 2 times 2 is 4, and 5 times 2 is 10. Then over here, we've got 4 times 1 is 4 carbon, 2 times 2 is 4 hydrogen, and then we've got 4 times 2 is 8, 2 times 1 is 2, 8 plus 2 is 10. So yes, it is balanced because we have 4, 4, 4, 4, 10, 10. All right, what goes in the empty space? So we've got to look at iron, see how many irons we have on the product side, and then figure out how to get that on that side. So on the product side, 2 times 2 is 4. So over here, how would we get 4? Well, there's no subscript, so that means it's 1. So 4 divided by 1 equals what? And that would be 4. So 4 is what goes in that blank. All right, is this equation balanced? So we've got to figure it out. Now, I can look at it, and I don't even have to do all of that. There's only one carbon over here, and there's carbon here and there. So I know it's not balanced. There's 3 oxygens just right there, and there's only 3 on this side, and there's more oxygen there and there. And for all the reasons, no, that's not balanced. I don't even need to think that hard about it. What goes in the empty space? So we've got to figure out how many carbons are there on the reactant side to figure out how many carbons we need on the product side. So over here, there's a subscript of 1. So 2 times 1, so there's 2 carbons. So we would need to put a 2 here because there's no subscript here, so it's times 1. What times 1 would give us 2? 2. And that should balance out the whole equation. All right, this is the one. What is the magical number? Sugar is evil, hint, hint, that balances the equation for photosynthesis and respiration. What goes in every one of these blanks? Now, you can go through and balance the equation, but hopefully you just remember that the magical number is 6. Now, I want to show you why it's 6, because we've got carbon, hydrogen, oxygen, carbon, hydrogen, oxygen. So we've got 1, 2, and 3, 6, 12, and 8. So we need 6 carbons, right? So we're going to put a 6 here, and that's going to give us 6 carbon. And that's also going to give us 12, 13 oxygen, not considering that 6 there. Okay, and then we know we need 12 hydrogen. So 6 times 2 is 12. So that gives us the 12 hydrogen. And then that ends up giving us 6 times 2 is 8, plus 6 is 18. 18, right? It's 18 total. 6 times 2 is 12, plus 6 is 18. Yes. Okay, my bad. So then we need 18 oxygens over here, but we've got to remember that there's 6 here. So 18 minus 6 is 12. We need this to be 12. So 6 times 2 is 12. So the magical number is 6. 6 goes in every blank. All right, that's the quiz. Hopefully you got a good little bit of review out of this video and are ready to take it now. I would very much request that you try your best on the quiz the first time through, and then ask for a retake after you watch the video again if you need to, and not actually watch the video while you're taking the quiz. At least watch it once, but while you watch it during. Watch it once before, and then watch it during if that's what you're going to do. But anyway. It's a crazy year this year, ain't it? All right. So message me if you have any questions. Have a lovely day. Make good decisions. Bye.